Okay, this problem says a clay cylinder of radius 20 centimeters on a potter's wheel spins at a constant rate of 10 revolutions per second. The potter applies a force of 10 newtons to the clay with his hand, where the coefficient of friction is 0.1 between his hands and the clay. Alright, so here's the cylinder, it's rotating like that. He applies a force perpendicular. Okay. And mu k, the kinetic coefficient of friction is 0.1. What is the power that the potter has to deliver to the wheels to keep it rotating at this constant rate? Okay, so this is the friction force in that direction. As the wheel is rotating in this direction, okay, the friction force is in that direction, and so let's calculate the friction force. 1 Newton. Okay, and the work done by friction is the rate at which, okay, the rate at which friction is doing work is it's all right. I'll do an absolute value. Power is that is torque times angular velocity. Okay. There's a formula similar to this. Power is, if you look up formulas from chapter 9 or something. Power is if you apply a force F and the object is moving at velocity v, the rate at which you're doing work is F dot v. Okay, so that's where this formula comes from. So, okay, so friction force times the moment arm. You need a cylinder of radius 20 centimeters times omega. So 1 Newton, the radius is 0.2 meters, and omega is 10 revolutions, which is 20 pi. Omega is 10 revolutions per second, 20 pi radians per second. Okay. So power, the rate at which friction is doing work is, again, 1 Newton times 0.2 meters. I'm just rewriting this down. 20 pi radians per second. So 4 watts. Okay. So, and so the motor has to be a 12.6 watt motor to keep the wheel rotating at constant rate. Okay, the friction is trying to slow it down, so to keep it going, you have to do work. The motor has to do work at the same rate. Okay. All right, it's 1:50. What I'm going to do is, you guys have a 5-minute break. I'm going to give you a summary of the next chapter so that when we start the slides, we can go through the slides fairly quickly. Okay, so you have a 5-minute break.
taking my word as law. He's not taking my word as law. I did the integral. He wants to know how this is equal to mass. Or
Well,
ask your question.
Okay, so when you did the disk, wait, do you have the problem on here?
Yeah, the problem is on the previous page.
I'll do it on the previous page.
So, this is the problem.